Okay, hello everyone. So this is a replacement recording for the live Lecture 7 recording, which unfortunately was lost. And so what I'm going to do is I'm just going to go over the notes that I wrote up during the lecture this morning, and I'm just going to explain them using the pointer. So I don't think I'll be writing down anything new, so you don't have to take extra notes in case you already took notes and you're rewatching this video. And if this is the first time that you're seeing these notes about regular expressions, the notes are posted, so that'll help keep up. Okay. So this lecture was about regular expressions. So what are actually regular expressions? Let me give you the informal definition that I introduced at the beginning of class. Regular expressions are these mathematical objects which explicitly describe the patterns in strings. So while finite automaton were computational machines that accepted strings, regular expressions are these mathematical objects which describe the patterns of strings. So they're doing something different than accepting. They're saying this is what the string should look like. So for instance, in this first example here, I had the alphabet 0, 1, and the regular expression I had was 0, 1 star, 0, 1. Okay, and so you'll notice that instead of saying this plus here, I'm going to say or, and you'll see why that makes sense in a few pages where I sort of formally define what each of these regular expression operators mean. But for now, let's just look at the intuitive idea of what this regular expression is saying, what pattern it's describing, by breaking it down case by case. So this regular expression starts with this 0 or 1. What does this 0 or 1 say? It says that the string has either a 0 or a 1. Right? So at some position, the string either has a 0 or it has a 1. Now what happens if I augment this with a star? Well, it says that the string has either a 0 or a 1, but this occurs any number of times. So I have possibly multiple positions in my string, and at each of those I either have a 0 or a 1. Okay. And then lastly, what happens when I add this 0, 1 to this 0, 1 whole star? Well, it's saying that the string must now start with any number of zeros and ones. So that means that at every position, it's either 0 or a 1. But at the very end, it has to match this pattern 0, 1. And what this pattern is matching is strings that end with 0, 1 exactly. Okay. So this regular expression matches strings that have any number of zeros and ones in any sequence, and then end in 0, 1. And so what we would say formally is we would say the language described by R, so L of R, is the set of strings of the alphabet 0, 1 for which those strings end in 0, 1. And what I was saying in class, I was saying that regular expressions and FAs are really two sides of the same coin because both are really talking about regular languages. So regular expressions describe regular languages, and we'll prove that towards the end of class or of this video or of one of the videos I'm going to post. And FAs are computational machines which accept exactly regular languages. And the analogy here is an analogy of programming languages. So for instance, you could have in declarative programming languages, you have, for instance, SQL, where you say, I would like from this table of entries, the entries with the name Cesare. Okay? So you're declaring what you want the program to do, and that's exactly what regular expressions are saying. They're saying, these are the strings that I'd like to match with. Whereas for FAs, these are more like imperative programming languages. So in imperative programming languages, you specify exactly how a program should operate such that it gives you this output. So in other words, FAs, much like imperative programming languages, tell you the how, whereas regular expressions, much like declarative programming languages, tell you the what. Okay. So what do I want, and how do I accept it? Okay. And so there's this dichotomy you see between regular expressions and FAs.